Welcome to MyOrangeSlate.com from Futurism. Friends, today we'll see races on a linear race course. Friends, most of the questions on races on a linear race course, what we find is two objects moving simultaneously. And when two objects are moving simultaneously, invariably we find that either the time for which both the objects are moving is same, or the distance that both the objects cover is same. We know that speed is equal to distance upon time. Thus for two objects we can express as v1 is equal to d1 upon t1 and v2 is equal to d2 upon t2. And if the time for which both the objects are moving is same, we get that ratio of speed is equal to ratio of distance traveled. Because we can express these two formulae as v1 upon v2 is equal to d1 upon t divided by d2 upon t. Since time is same, t would cancel and we will have v1 upon v2 is equal to d1 upon d2. Similarly, if for the two objects the distance travelled is same, we can express this formula as v1 over v2 is equal to d over t1 divided by d over t2, and that gives us d into t2 over d into t1, and d cancels. Thus we have v1 over v2 is equal to t2 over t1, and thus we get ratio of speed is equal to inverse ratio of time. Once we express a question in ratio form, as in ratio of distance or inverse ratio of time, it becomes easier to resolve the equation and find the answer faster. So we must always try and express the question in the ratio form. We'll also see certain phrasing of the questions on races. When it is said that A beats B by 10 meters in a 100-meter race, what do we understand, friends? Starting at the same time, A completes the race, that is A runs 100 meters. B is 10 meters short of the destination, thus B runs 90 meters. The time for both is same, so we get that VA upon VB is equal to 100 over 90 or 10 over 9. The same thing as A beats B by 10 meters in a 100-meter race can also be said as A can give B a start of 10 meters in a 100-meter race. This in turn means if A starts at the starting point, B starts at 10-meter mark, and still both complete the race at the same time. Thus once again, B covers 90 meters in the time that A takes to complete 100 meters. And since time is same in both these cases, what we get is ratio of speed is equal to ratio of distance travelled, and hence v1 upon v2 is equal to d1 over d2, and that is equal to 10 over 9. Same as distance, you may find similar phrasing with regard to time as well, where the sentence may say that A beats B by 2 seconds in a 100-meter race. A beats B, thus B must take more time than A, and the difference in the time must be 2 seconds. Thus if A completes the race in t seconds, B should take t plus 2 seconds. Now in this case, the distance traveled is same for both, and hence ratio of speed is equal to inverse ratio of distance traveled. Same thing as A beats B by 2 seconds can also be said as A can give B a start of 2 seconds. And in this case, B would start the race 2 seconds before A does, and both reach the destination at the same time. Thus, once again, if A takes t seconds, B would take t plus 2 seconds. And we get ratio of speed is equal to inverse ratio of time, or V1 over V2 is equal to t plus 2 over t. Once we express questions in the ratio form, as I said earlier, it becomes easier to resolve the questions. Let us see with the help of few examples. A runs 1 and 3/8 times as fast as B. If A gives B a start of 120 meters, how far the winning post must be so that A and B reach the post at the same time. Now since A gives B 120 meters start, A must run 120 meters more than B. Thus if B runs x meters, A must run x plus 120 meters. Also, A runs 1 and 3/8 times as fast as B. Thus we know that VA over VB is equal to 11 over 8. This we can get as converting 1 and 3/8 times into a fractional form. We get VA is equal to 11 over 8 times VB, and that gives us the ratio speed as 11 over 8. And while A gives B a start of 120 meter and both reach the post at the same time, that means time for which both are moving is same, and hence ratio speed is equal to ratio of distance traveled, and hence we get 11 over 8 is equal to x plus 120 over x. Now resolving this equation, we get the value of x is equal to 320. But beware friends, 320 would always be there in the option and very likely to be marked and made a mistake here, because how far the winning post must be, that refers to the total distance to be traveled, and that is the distance which is traveled by A and not by B. Hence the correct answer would be 320 plus 120, that is 440. So how do we avoid this kind of mistakes in the test setup? By making appropriate assumptions here. Since the question is how far the winning post must be, our value of x must give us answer to this particular question. Hence we must assume the distance travelled by A to be x and distance travelled by B to be x minus 120. Friends, always remember, the x that you assume in any question must directly give answer to the question posed to you. And if we take this, A travels x meters and B travels x minus 120 meters, what we get is 11 over 8 is equal to x over x minus 120. But friends, we do not cross multiply here. We can use dividendo, but even that is not very efficient process. So what do we do? We see here that difference between numerator and denominator is 3 on the left hand side. And on the right hand side, the difference between numerator and denominator is 120. Now since 3 multiplied by 40 gives us 120, 11 multiplied by 40 will give us x. Or 8 multiplied by 40 will give us x minus 120. So friends, you simply have to find the difference between numerator and denominator on the left hand side and on the right hand side and see how many times one is of the other. Once again I shall repeat. The difference between numerator and denominator on the left hand side is 3. On right hand side it is 120. Since right side value is 40 times left side value, right side numerator would be 40 times left side numerator. And similarly, right side denominator would be 40 times left side denominator. And this directly gives us answer as 440 meters. Right friends? Try this another question. A can give B 40 meters start and C 70 meters start in a kilometer race. How many meters start can B give C in a kilometer race? 30 meters? No friends. In mathematics, almost every question has very simple, straightforward and a wrong answer. And 30 meters is such an answer. What you can see here is in a kilometer race, thus they race for 1000 meters. And if A gives B 40 meters start, when A runs 1000 meters, B runs 960 meters. And A can give C 70 meters start. The C runs 930 meters. So we can say that we can give C 30 meter start in 960 meter race, not in a kilometer race. Thus when B runs 960 meters, C runs 930 meters. So when B runs 1000 meters, how many meters does C run? And we can resolve this calculation and get 968.75 as the answer. Subtracting this from 1000, we get 31.25 meters start that B can give C in a kilometer race. Or instead we can think little differently to minimize calculation, that in 960 meters we can give C 30 meters start. So in 1000 meters he can give how much? And then the calculation becomes simple, 1000 into 30 over 960, and that gives us 1000 over 32. Both are divisible by 8, so 125 over 4, and that gives us the answer as 31.25 meters straight away. We'll see another question. In a kilometer race, A beats B by 40 meters or 7 seconds. Find A's time over the course. In a kilometer race, once again a 1000 meter race, A beats B by 40 meters. Thus when A runs 1000 meters, B runs 960 meters, or by 7 seconds. Thus if A takes T seconds to cover 1000 meters, B takes T plus 7 seconds to cover 1000 meters. Now how do we combine these two information? Either we can visualize the movement of A and B over the race course. Thus both of them start the race at the same time. When A covers 1000 meters, B is 40 meters short of destination. Thus B has covered 960 meters. And B covers the distance in 7 seconds more than A does. So we can say that B covers this 40 meters in 7 seconds. Now if B covers 40 meters in 7 seconds, he covers 960 meters. Why did we take 960 meters, friends? Because the time for B to cover 960 meters is same as time for A to cover 1000 meters. And we have to find A's time over the course. Thus we can take the question as, when B covers 40 meters, he takes 7 seconds. To cover 960 meters, he would take 960 into 7 divided by 40, and that is 24 into 7, 168 seconds. There is no need for us to find the time for B for 1 kilometer and then subtract 7 seconds to get time for A, when we can directly find time for A to cover 1000 meters. Thus, when A covers 1000 meters, B covers 960 meters in the same t seconds. B covers remaining 40 meters in 7 seconds. Thus we can say that if B covers 40 meters in 7 seconds, he covers 960 meters in how much? And the calculation gives us 168 seconds as the time, which is for A to cover 1000 meters. Alternatively, going by the ratio approach that we saw earlier, there are two cases. In one, A beats B by 40 meters. In the other, A beats B by 7 seconds. We know that ratio of speed is equal to ratio of distance, that is 1000 upon 960, and that is equal to inverse ratio of time, that is t plus 7 over t. Now 1000 over 960 is 25 over 24, and we see that on the left hand side the difference is 1 between numerator and denominator. On the right hand side the difference is 7. So right hand side value is 7 times the left hand side value. So 24 into 7 gives us 168 seconds as the value of t. Friends, try solving this question. You can take up to 2 minutes to solve the question. Pause the video. Friends, if we see in this question, in a kilometer race, once again a 1000-meter race, if A gives B 40 meter start, A wins by 19 seconds. So even if A gives B a start of 40 meters, A wins by 19 seconds. Thus neither the distance traveled by both is same, nor the time taken by both is same. Also, if A gives B 30 second start, B wins by 40 meters. Once again, neither the time is same, nor the distance is same. So first thing we realize here is, we cannot express this question in ratio form. There are two cases given. In the first case, when A gives B 40 meter start, A covers 1000 meters and B covers 960 meters. A wins by 19 seconds. That means A takes t seconds and B takes t plus 19 seconds. This is the case 1. Now in case 2, A gives B 30 second start and B wins by 40 meters. Since B wins by 40 meters, B has now traveled 1000 meters, whereas A has covered only 960 meters. A gives B 30 second start, so if A has run for t seconds, B has run for t plus 30 seconds. But then friends, can we take t seconds here? Actually no, because what we have assumed t to be is time for A to run 1000 meters. Thus for 960 meters, the time that A would take would be 24 by 25 t. And thus the time that B takes to cover 1000 meters is 24 over 25 t plus 30. Now by equating speed of B in case 1 with that in case 2, we can find the value of t. So what we get here is t seconds for A to cover 1000 meters, t plus 19 seconds for B to cover 960 meters, 24 by 25 t seconds for A to cover 960 meters, and 24 by 25 t plus 30 seconds for B to cover 1000 meters. Now if we equate speed of B in two cases, what we get is 960 divided by t plus 19 must be equal to 1000 divided by 24 by 25 t plus 30. Now friends, this calculation seems to be intimidating, right? But then even this calculation, if we do little intelligently, we can resolve this relatively easier than what it looks like. So this is the equation that we have. Taking numerals on one side and the unknown on the other side, we can make this equation as 960 over 1000 is equal to t plus 19 over 24 over 25 t plus 30. Now multiplying numerator and the denominator with 25, which is the denominator here, what we get is 25t plus 475 is equal to 24t plus 750. Whereas on the left hand side, we get 24 over 25. Now friends, this is the equation that if you use componendo dividendo, what we get is 25 plus 24 over 25 minus 24. That is denominator plus numerator divided by denominator minus numerator. What we get here is 49t plus 1225 divided by 275 minus t. That is denominator minus numerator. Gives us 750 minus 475 as 275 and 24t minus 25t as minus t. Now we can take 49 common here, and that gives us 49 into t plus 25. Componendo here gives us 49. Thus we get the expression as 49 over 1 is equal to 49 into t plus 25 over 275 minus t. And since 49 we cancel, we get 275 minus t is equal to t plus 25 or t is equal to 125. That is time for A to cover 1000 meters. So this is 125. So B's time, of course, it's not 144 friends, because it's time for B to cover only 960 meters. We have to take t is equal to 125 in this particular formula, this particular equation, and that gives us time for B to cover 1000 meters as 150 seconds. Right friends? We'll see questions on speed change, where an object changes its speed after covering certain distance of the journey. Say normally it takes a train 3 hours to run from station A to station B. One day, due to minor trouble, the train had to reduce its speed by 12 km per hour, and so it took 3/4 of an hour more than normal. What is the distance? A to B. So friends, the normal time is given as 3 hours. The change in the speed is given as 12 km per hour, and as a result, the difference in the time is given as 3/4 of an hour. So simply put, if we assume that v is the normal speed, distance is equal to speed into time, and that is equal to v into 3, and on this particular day it is v minus 12 into 3 plus 3/4, and hence we get v over v minus 12 is equal to, this is 15 by 4, so we get 15 over 4 into 3, that is 12. Now difference here is 3, difference on this side is 12, so left hand side is 4 times the right hand side, so 15 into 4, v is equal to 60. And then we know that distance is equal to 60 into 3, that is 180 kilometers. Right, friends? So friends, what we get here is the distance is equal to normal speed into 3 hours, which is equal to the reduced speed, that is v minus 12, into 3 and 3/4 hours, which is equal to 15 by 4. So we get v into 3 is equal to 15 by 4 into v minus 12. From this we get v over v minus 12 is equal to 15 over 3 into 4, that is 12. Now difference on the right hand side is 3, that on the left hand side is 12. Thus we know that left hand side is 4 times the right hand side. So we get v is equal to 15 into 4, 60. And that gives us this distance is equal to 180 kilometers. But friends, as I normally suggest, we should try and solve questions without any need to write down. Now in this question, if we focus on the values given in the question, normally it takes a train 3 hours. One day, due to minor trouble, the train had to reduce its speed by 12 km per hour. So before we read further, if we combine this information, what we understand is, in the normal time, the train covers 36 kilometers less. Because in 3 hours, it should reach the destination, but it covers 12 kilometers less per hour, and hence 36 kilometers less in 3 hours. Now this is the distance that train covers in 3/4 of an hour. So from this we get the reduced speed of the train as 48 km per hour, and thus the normal speed becomes 60 km per hour, 48 plus 12, and distance we get is 180 kilometers. Once again, since the speed reduces by 12 km per hour, the train covers 36 kilometers less in the normal 3 hours. The distance which it covers in additional 3/4 of an hour. Thus we get the reduced speed as 48 km per hour, since 36 kilometers in 3/4 of an hour. Now this gives us the normal speed as 60 km per hour, adding 12 to 48, and the distance as 180 kilometers, multiplying the normal speed with normal time, that is 3 hours. Yet again, alternatively, if we see, the time has increased by 1/4 of the normal time, And this we get by dividing increased time by the normal time. That is 3/4 divided by 3. So since time has increased by 1/4, the speed must have reduced by 1/5. It's very simple logic that if A multiplied by B is constant, increase of 1 upon x fraction of A implies that there must be a decrease of 1 upon x plus 1 part of B. We know that speed into time is constant, the distance. So if time is increased by 1/4, the speed must decrease by 1/5. And 1/5 of the normal speed is 12 km per hour. So the normal speed is 60 km per hour. This gives us the distance as 180 kilometers. We'll see another question. A car covers 420 km with a constant speed. If its speed were 10 km per hour more, it would have taken an hour less to travel the distance. Find the speed of the car. A car covers 420 km with a constant speed. Say the speed is v. And the time taken is t. Thus we know Vt is equal to 420. If the speed were 10 km per hour more, thus if the speed were v plus 10, it would have taken an hour less. It would have taken an hour less to travel the same distance. We can resolve these equations simultaneously by forming quadratic equation. Opening these brackets, we get Vt plus 10t minus v minus 10 is equal to 420. Vt is equal to 420 and v is equal to 420 upon t would give us the equation as 10t minus 420 upon t minus 10 is equal to 0. Since each term is multiple of 10, we can divide this by 10 and we can multiply with t. So we get the equation as t square minus t minus 42 is equal to 0. Solving this quadratic, we get t is equal to 7, which gives us the speed as 60 kilometers per hour. But friends, alternatively, instead of going for such elaborate calculation, we can focus on the values where it says that car covers 420 kilometers, the difference in the speed is 10 km per hour and difference in time is 1 hour. We know that speed into time is equal to distance, which is 420 here. Now, given the values, we can safely assume that the time in both cases is in integer and so is the speed. Not only that, we can also assume that speed most likely should be multiple of 10. Now given that, we can simply go by options if we have them, or we can go by trial and error. The difference of 10 in speed should give us difference of 1 in time. So various combinations of speed we get is 20 and 30 with the difference of 10, 30 and 40, 40 and 50, 50 and 60, 60 and 70 and so on. Speed cannot be 50 because we get t in fractions. So this option is ruled out. Similarly, this is also ruled out. Speed is 40 again we get a fraction, so it is ruled out. Now 20 and 30 would not give us a difference of 1 in time, so the answer must be 60 and 70 as speeds. When 60 is the speed, 7 hours is the time. When 70 is the speed, 6 hours is the time. So we know that speed must be 60 km per hour. Is that clear, friends? We know that speed into time is equal to distance. Given that speed changes by 10 km per hour and time changes by 1 hour, we can safely assume that speed must be in multiple of 10 and t must be an integer. Taking various values of speed cannot be 40 or 50 because that gives us time in fraction, and hence only possible options for us are 20 and 30 to be speeds or 60 and 70, and we know that 60-70 gives us the answer. Right, friends? Let us see another question. A cyclist traveled every hour 1 km more than he had intended to travel in 1 1/4 hours. The first thing that we should do is convert these into improper fraction as 5/4 hours. As a result, he covered a distance of 96 kilometers 2 hours sooner than he thought he would. Can you try solving this question, friends? You can once again pause the video and take 2 minutes to solve the question. Now we need to analyze the first sentence first. He had intended to travel in 1 1/4 hours. When we have to analyze the sentence, we should normally do it from the last clause. So in 5/4 hours, he would intend to travel 5/4 v kilometers. And he traveled 1 kilometer more than this. That is 5/4 v plus 1. And this is the distance that he traveled every hour. So this is his actual speed, 5/4 v plus 1. As a result, he covered a distance 96 km 2 hours sooner than he thought he would. So if he thought that he would cover the distance in t hours, he covered it 2 hours sooner, that is t minus 2. The other equation we can form is his intended speed and his expected time, that is v into t is equal to 96. Friends, once again, same as the previous question, we can resolve these two equations simultaneously by forming a quadratic equation. But even after you have made this equation, if you rework on the assumption that since you have 4 in the denominator here, assume the intended speed as 4v and not just v. If you make equation like this, after elaborate calculations, we get the value of speed is equal to 16. V is equal to 12, and that gives us speed is equal to 16 km per hour. But if we assume the intended speed to be 4v and the expected time to be t, what we get is 4vt is equal to 96. That is speed into time, and 5v plus 1 into t minus 2 is equal to 96. Now if we see here, we have been able to eliminate the fraction. Resolving these two equations, we get v is equal to 3, and that gives us the speed, that is 5v plus 1 is equal to 16 km per hour. We basically get easier calculation if we assume the unknown wisely. We assumed it to be 4v because we had 4 in denominator here. So to eliminate the fractions and denominators, we can rework on the assumption and resolve the question smartly. Alternatively, further if we see the difference in time is 2 hours and speed and time should largely be integers, we know that speed into time is equal to 96 and difference in time is 2 hours. So the time in the two cases can be 1 and 3 hours, or 2 and 4, or 3 and 5, or 4 and 6, or 5 and 7, or 6 and 8, and so on. Now 3 and 5 and 5 and 7 is not possible because t is equal to 5 does not give us speed in integers. If we take t is equal to 1 hour and 3 hours, we get speed is equal to 96 and 32. So difference being huge, it cannot be 1 kilometer more than 1 and 1/4 hours. It does not fit into that. If we take 2 and 4, once again, it is almost double. We get the speed which is twice in the first case as in the second, which is not possible. If we take 4 and 6 as time, we get 24 hours and 16 hours. Now 16 into 5 by 4 plus 1, this is only 21. 6 and 8 hours gives us 16 km per hour and 12 km per hour. Now 12 into 5 by 4, this is 15 plus 1 is 16. This is the answer. And we get V is equal to 16 km per hour. We'll see the questions on movement between 2 points. Here it says that a bus A left town M for another town N at 5 am. At 6:30 am, another bus B left M for N at the speed 5 km per hour more than that of bus A. At 9:30 pm on the same day, the buses were 21 km apart. Find the speed of bus A. Can you try solving this question, friends? You can pause the video and take 2 minutes to solve. Once again, if you visualize the movement of A and B from point M to point N, A starts at 5 am, B starts at 6:30 am at a speed 5 km more than that of bus A. At 9:30 pm, the buses are 21 kilometers apart. Once again, friends, if you see, the time is not same because A starts at 5 whereas B starts at 6:30 and they move till 9:30 pm. Also the distance isn't same because both start from M but they are 21 kilometers apart when they are observed at 9:30 pm. Thus we need to make an equation. We cannot express this question in the ratio form. When we have to make an equation, often the absolute difference or summation can give us a start. Here the difference in the distance traveled by the two buses is 21 kilometers. So we can make an equation for distance, that is dA minus dB is equal to 21. Or is it 21? Because what is given here is the buses were 21 kilometers apart. The question does not say which bus was leading over the other or which bus was trailing the other. And hence we must take this as plus or minus 21. Now distance is equal to speed into time. The speed of bus A is of course VA, and time that A runs is for is 16.5 hours. Did you make the mistake of not reading AM and PM, friends? minus VA plus 5 into 15 hours, and this should be equal to plus or minus 21. Resolving this, we get two answers for VA. That is 36 or 64 kilometers per hour. We'll see another question. Two men left simultaneously two places A and B. One of them left A for B and other B for A. Both traveled, each with his uniform velocity. Having arrived at the destination, they turned back without stopping and traveled to their starting points. First time they met 12 kilometers from B. The second time they met 6 kilometers from A. Find the distance A to B. Once again, friends, pause the video and try this question. Let us see how best we can solve this question. Visualizing the movement of two men between A and B. The first time they met 12 kilometers from B, and second time they met 6 kilometers from A. Since both of them start at the same time from 2 points A and B and move towards each other, when they meet for the first time, the time for which both have been moving must be same, and hence when time is same, we know that ratio of speed is equal to ratio of distance traveled. Thus we get VA upon VB is equal to x minus 12 upon 12. X minus 12 being the distance that person who started from A covered, and 12 kilometers is the distance that person who started from B covered. And similarly for the second meeting, person who started from A covers the entire distance x kilometers, and on return he covers x minus 6 kilometers. Thus he has covered 2x minus 6 kilometers, whereas person who started from B covers x kilometers and then 6 kilometers. Thus he has covered x plus 6 kilometers. Now friends, we know that the signs of constant term in denominator and numerator are different. Thus we can use componendo in order to resolve this question. Adding denominator to numerator, we get x upon 12 is equal to 3x upon x plus 6. So x gets cancelled, and then cross multiplying, we get the value of x is equal to 30. Once again, for the first meeting, A covers distance equal to x minus 12 kilometers, whereas B covers distance equal to 12 kilometers. Since time is same, we know that ratio of speed is equal to ratio of distance traveled. For the second meeting, A covers distance equal to 2x minus 6 kilometers, that is from starting to B and then on the way back up to M2, whereas B covers distance equal to x plus 6 kilometers, that is the whole distance x plus 6. Using componendo, we get x over 12 is equal to 3x over x plus 6. Thus x is equal to 30 kilometers. Alternatively, a little complex but quicker solution, the understanding that can help us solve different questions on the similar lines too. When two persons start from two different points and move towards each other, for the first meeting, that is for M1, they together cover total distance x meters or x kilometers. That is this plus this. So for the first meeting, they cover distance equal to x. But for each subsequent meeting, they need to cover total distance equal to 2x. Because from M1, A has to move to B, and then he has to move to M2. Whereas person who started from B has to first move to A, then he has to move to M2. And thus we can see that the total distance traveled between two meetings is 2x. The distance 2x for each successive meeting. So we know that for the first meeting, it is x kilometers. For the second meeting, that is first to second, it is 2x kilometers. So by the time they meet for second time, the total distance traveled by them together is 3x. Now friends, we know that if the total distance traveled by them is x, B has covered 12 kilometers. So if total distance traveled by the two is 3x, B must have walked for 36 kilometers. And this is equal to x plus 6, and hence the distance x must be 30 kilometers. Once again I shall repeat, when two persons start in opposite directions on a linear course, they together travel distance x for the first meeting, that is the total distance between 2 points, and distance 2x for each successive meeting. That is after first meeting, distance 2x for the second meeting, then another 2x for the third meeting, and so on. Thus up to the time they meet for the second time, they would have traveled total distance of 3x kilometers. Now in the total distance x, B covers 12 kilometers, so in total distance 3x, B must cover 36 kilometers, which is x plus 6, thus x is equal to 30 kilometers. Right friends? Now it's time for trivia. It has been a long session. Thank you friends.